Okay, we are going to look at the Cartesian equation of a plane. So this is the form of it, ax plus by plus cz plus d. So recall, we already looked at the Cartesian equation of a line, where you can get the normal vector, which is perpendicular to the line. Same concept for the plane. So when it's in this form, the normal vector is going to be those coefficients a, b, c, and that normal vector and all the parallel vectors to that normal vector are going to be perpendicular to the plane. So we're going to look at some situations on how to come up with and generate this Cartesian equation of a plane now. So first one, if you are given the point on the plane and the normal vector of the plane. So you've already been given the normal vector. So this one is pretty direct. So here is my guide that I like to call it. So I'm just going to sub in -1, 2, and 6 for ABC. So you can see here that we just need to calculate D, and that's where the point comes in. So I'm going to take this point and now I'm going to sub it into X, Y, and Z. Okay, so I'm going to work this out. So we get it down to this, that D is going to be -15. And I'm just going to take that and I'm going to sub that back in there. Now again, so there's Cartesian equation of the plane. Now again, you could use parallel vectors to that normal vector and you would still be correct. So you're going to have a wide variety of infinitely different looking equations in Cartesian form for the plane. But if you just want to go straight forward, you can just do what I just did here. Okay, now this one's an interesting one. So when you're given 3 points on the plane, so let's look here. So we got our plane. And you got 3 points on the plane. So what you need here, like you still have to go into this form. So recall that now we know the normal vector of that plane is ABC. So normal vectors we know are perpendicular vectors. So how do we generate perpendicular vectors? Well, what we're going to have to do here in this situation is we're going to have to use a cross product. Because the cross product is how we generate perpendicular vectors, two lines and out of planes. So again, you're going to have to come up with two vectors here. So any combinations that you want. So I'm going to go with AB. And again, you can refer to a prior video on how to do the change X, Y, and Z. And I'm going to go for AC. Now again, now I'm going to cross those two. So you can go AB cross AC or AC cross AB, same thing. So just save a little bit of time. When we cross those two, I'm going to get the vector -5, -3, -20. So again, refer to a prior video on how to calculate the cross product. See, now this right here is going to act as your normal vector because the cross product produces perpendicular vectors. So now I can take that and I can sub it into 4A, B, and C. Now same task, we need to come up with D. Now you can use any of these points because they all lie on the plane. Oops, I don't want to see that yet. So I'm going to choose the first one. Okay, just to save a little bit of time, that is going to work out to 101. And over here, I'm going to write out my full Cartesian equation. Again, that can have many different looks. If you did AC cross AB, you would get the opposite normal vector, which is perfectly fine because it's still perpendicular. You could go with parallel normal vectors, same idea. You are always going to get that same equation that represents that plane in Cartesian form. But it might look different depending on the vectors, but they are all equal. Okay, so now situation here, what about if you are given the equation of plane? Well, it's pretty much like what we just did there. You're still going to have to generate a normal vector. So you're still going to have to do the cross product. So cross product can only be done between vectors. So what you want to do is you want to do the cross product with those two direction vectors. So in this case here, I would be going 1, 0, 2. Cross negative 1, 3, 4. So again, you can refer to a prior video to practice how to do the cross product if you need a little bit more work with that, and that's perfectly fine. So that'll come out to that, and then pretty much more of the same here. Okay, so in this case here, you need to submit a point, so you can use a point here on the plane. And just to save a little bit of time, it's going to work out to 21. So then this would be the Cartesian equation of the plane. And again, that could be one of many different looking solutions, depending on if you chose parallel vectors to your normal, and that's perfectly fine. Okay, now when you get the normal vector of a plane, you can use it to determine if the planes are parallel or perpendicular, and to determine the angle between two planes, just like you did with the lines with the normal vectors. So again, parallel planes. Now these planes, they're all over the place, and they intersect, and a lot of them are parallel. So that's not a very good plane there. So let me see if I can do a better job there. Okay, so parallel planes, if you have two planes and you want to determine if they're parallel, so you would look at their two normals. So you would get the normal of that plane and the normal of this plane. We'll call it normal 1, normal 2. And so then if you can, doesn't matter what we call it, let's just use t. If you can factor out a value from one of the normals and produce the other normal vector, then they're parallel, just like you can do with the lines. If you want to see if planes are perpendicular, same that we did with the lines, if the dot product is 0, so this is the one you're going to use for parallel, and this is what we're going to use for perpendicular. If you take those two planes and you do the dot product and it comes out to 0, you can conclude that they are perpendicular. So again, that would look something like this. So the normal vector has quite a few uses. So again, perpendicular planes, do they intersect each other at 90 degrees? So you get the normal vector, you can use that test. And if you want to find the angle between two planes, you can use their normal vectors, just like you did with the lines, and you would use a dot product. Okay, so that is a look at the Cartesian equation of a plane